Hi all, I'm Aksa Johnson, and today I'll be presenting my project titled Mapping Nutritional Inequality, a spatial analysis of food purchases. We are going to explore something that affects all of us. What we eat, and more importantly, how well we live and how much we earn influences the quality of food we purchase. Let me start by setting the scene. When we talk about nutritional inequality, we are talking about the fact that not everyone has equal access to healthy food. This is not random. It's shaped by factors like how much money families have and the age makeup of communities. Here is a sobering statistic. Globally, over 390 million children and teenagers are overweight, and 160 million of them are living with obesity. It shows that poor diet is not just an adult issue anymore. Early eating habits shape health for life, and I wanted to understand where and why children are most at risk of poor nutrition. Why does this matter? Because if we can understand where nutritional problems are worst and WHO is most affected, we can design better policies and interventions. That's exactly what this research aims to do. So, where are we focusing this study? We are looking at the Greater London, home to over 9 million people with enormous differences in income, ethnicity, and health outcomes. In London, specifically, the obesity picture is concerning. About 12% of younger children aged 2 to 10 years are obese, and this jumps to 19% for older children aged between 11 to 15 years are. These are not just numbers. These are real children whose health is being affected right now. Our goal is to use real supermarket data to understand how diet quality varies across this diversity and crucially how income and age influence the nutritional environment children are growing up in. Now you might be wondering, where does this data come from? Our data comes from Tesco, the UK's largest supermarket chain. It includes data from 1.6 million customers with over 422 million food items purchased from 411 Tesco stores across Greater London. The data was collected through Tesco's Clubcard loyalty system, which tracks purchases anonymously, and no personal information is included. This dataset shows what kind of food people buy and where they buy them, which make it a perfect resource for mapping food purchasing behavior across London. Let me show you what's actually in this dataset. This dataset is incredibly rich. For every purchase, we have nutritional content that is calories, sugar, fat, saturated fat, protein, all the things you see on food label. Energy breakdown, how much energy comes from carbs, fat, or protein. Food categories like fruits and vegetables, meat, dairy, or sweet. Demographic information about the population. That means their age, gender, and how densely populated an area is. Now let me explain how we have organized this geographically. You're looking at the map of Greater London divided into look like puzzle pieces. Each piece is called an MSOA. A MSOA is like the neighborhood unit used for statistic in England. Each one contains nearly 5,000 to 15,000 residents, about the size of a small town or a few city blocks. By analyzing Tesco data at MSOA level, I could compare food purchases across hundreds of small areas within the London and see how diet quality changes from one neighborhood to another. Now, with all this data, how do we actually measure if a diet is healthy or not? That's where things get interesting. To assess the diet quality, we focus on five key nutritional components: energy, sugar, saturated fat, which causes different health problems to our body, and fiber and nutrient diversity, which is good for our health. And we transformed each nutritional variable into set scores using this equation. So we can put all variables on a same scale. And that's why we can compare and combine them fairly. Let me show you how we combine these into a single score. We created a composite measure called Nutritional Quality Score or NQS for short. How do we calculate it? We take the set score I just mentioned and use this formula. NQS equal to set fiber plus Z nutrient diversity minus Z sugar minus Z saturated fat minus Z calories. In plain English, we add points for good things, that is fiber and nutrient diversity, which is good for our health, and we subtract points for bad things, which is calories, sugar, saturated fat, which is bad for our health. The higher NQS values mean healthier food purchases, while lower values means less healthy one. This is the heart of our findings. What you are seeing is the nutritional quality score mapped across Greater London. The color tells us the story. We can see the West and Southwest London, which is in green in color, have healthier diet, but the East and Southeast side of London, which is purple in color, have poorer diet quality. There is a clear geographic inequality. Where you live in London matters for the quality of food and you are likely to purchase. But geography alone does not explain this. Let's look at who is living in these areas. This graph shows the relationship between the population of elderly people and the nutritional quality score. In here, the red line is almost flat, meaning there is no clear relationship between the number of elderly people and the nutritional quality of food purchases. Now, look at the adult graph. There was a positive relationship. Areas with more adults tend to have higher NQS. Now, here is the critical finding. Let's look at children. This is the most concerning graph. Notice the red line slopes sharply downward. What does this mean? Areas with more children tend to have lower NQS, which means poor diet quality. Children emerge as the most vulnerable group when it comes to unhealthy food purchasing patterns. Families with more children may be struggling to afford healthier options or may be opting for cheaper, calorie-dense processed food. This finding is so important that we decided to dig deeper with age-specific analysis. Why do we need age-specific scores? The overall NQ shows the diet quality by area, but not everyone eats the same way. A household with young children has very different purchasing patterns than a household of adults or elderly people. To understand diet quality by age, I created age-specific NQS value. Each area already had an NQS, but every area has a different mix of children, adult, and elderly people. So, I multiplied each area's NQS by the proportion of each age group in that area. Let me show you what happens when we map the children's score. This is the children's specific NQS map. The pattern should look familiar, but it's even more pronounced. The green areas like Richmond, Kingston, parts of Western and Northern London, the children here are exposed to healthier diet. The purple areas, Newham, Barking, Dagenham, parts of Croydon, children here are disproportionately exposed to lower quality diet. This is a public health concern. The nutritional environment children grow up in shapes their lifelong health outcomes. Their risk of obesity, diabetes, heart disease, even their educational performance. But we wanted to validate these patterns with actual health data. So we brought in childhood obesity statistic. Why more dataset? The Tesco dataset shows only what people buy but not why. We need to connect purchasing patterns to actual child health. We use National Child Measurement Program. This is NHS data measuring child's height and weight in school across London from 2011 to 2014. It covers two age groups, reception and year 6. But we are focusing on year 6 ages. Why? By ages 10 to 11, eating habits are established. National studies show obesity rates double between reception and year 6. This is the critical intervention point. Let me show you the obesity map. This map shows the percentage of year 6 children, that is aged between 10 to 11 years, who are overweight and obese across London. The darker areas in the eastern and southern parts of London shows high obesity areas, and the lighter areas in the western and southwestern London shows low obesity, which is in the light green color. Does this pattern look familiar? Compare this mentally to the NQS map we saw earlier. The areas with poor diet quality overlap significantly with areas of high childhood obesity. But there is one more crucial piece of puzzle: income. Why include income data? We suspected that economic factors play a major role in dietary quality. We obtained income data from Office for National Statistics at the same MSOI level. This gives us the mean household income for each neighborhood. By joining this with our Tesco data using the MSOI code, we can now examine whether wealthier areas really do purchase healthier food. Here is what we found. This graph tells us a story. On the horizontal axis, we have household income in pounds. On the vertical axis, we have NQS. And notice there is a clear positive relationship. As income increases, the NQS also increases. Now we have seen all the relationship individually, but how do they work together? That's where statistical modeling comes in. What is multiple linear regression? A multiple linear regression model is a way to see how two or more factors together influence one outcome. In this case, NQS. This is the equation for the model. And let me show you how we applied this. I used income and proportion of children as predictors, and here is what our equation will be. NQS equal to beta naught plus beta 1 into income plus beta 2 into proportion of children plus error term. And this is our final model equation. Let me break down what these numbers mean. First one is intercept. This is the baseline NQS when both income and child proportion are 0. Not practically meaningful, but statistically necessary. And the second one is proportion of children. This negative sign confirms our earlier finding. More children means lower NQS. And in here, the P is less than 0.001, which means this relationship is statistically significant. Then income. The positive sign confirms higher income leads to better NQS. For every £10,000 increase in household income, NQS increased by about 0.78 points, and it's also statistically significant. Let me summarize what we have discovered. In simple terms, this study shows that where you live in London affect how healthy your diet can be. People in wealthier areas have easy access to supermarket and affordable fresh food. People in low-income areas often live in food desert, places with limited or expensive healthy options. And most importantly, children are the group most affected. They don't control what food is available, but they face the long-term consequences of poor diets. That's why improving children's food environment is essential to closing the gap in between nutritional inequality. Overall, the project shows that nutritional inequality is socially structured, shaped by both economic condition and demographic composition, emphasizing the need for targeted nutritional policies and community level interventions. Finally, where do we go from here? This study opened several exciting research directions. The first thing is directly link NQS to obesity. We have shown they overlap geographically, but we want to develop explicit model testing whether lower NQS predict higher childhood obesity rates. And the second one is use advanced spatial model, specifically something called geographically weighted regression or GWR. This is a model that shows how the relationship between income and diet quality changes across London. Here are the resources that informed this work. I'm happy to share these or answer questions about any particular source. Thank you all for listening.